Welcome back, folks. We're going to look at multiplication. We're talking about all the operations that we've done in one dimensions, and we're extending them to two dimensions on the complex plane. This one's about multiplication. I want to change the way you think about multiplication. I want you to think about multiplication as stretching a vector and rotating a vector. And you've been doing this, okay? You've been doing this since grade school. You know, if I take 2 and I multiply by 3, you would say, well, that's 6, right? I take 2 and I stretch it to be 3 times as long, and that'd be good. Now the rotation, I want you to think of as maybe a good example of that would be 2 times -3. Okay, well, what we were taught, what I was taught, and I'm guessing it was similar for you, was that a positive times a negative is a negative, right? Yeah. So it's positive 2 times -3 is going to be -6. Okay. Well, what have I done? I've stretched the magnitude, and I've rotated the whole vector to point out the other direction. So this is going to look the same in polar. Okay. If I have two polar numbers, okay, each one has a magnitude r1 and r2, and each one has an angle θ1 and θ2. I'm going to stretch. Okay, that's stretch. And I'm going to rotate. Like that. Okay, so we're stretching and rotating. So let's think about that 2 times -3 example, right? So let's say, how do I want to do this? 2 times -3. We'll go old school. And that should be -6, right? Well, if I put those on a number line, all right, they're going to look like this. And I want you to think of them in polar form. It's not +2, it's 2 at an angle of 0. And it's not -3 so much as it's 3 at an angle of 180. Okay, let's do this. I like my colors. -3. Okay, and I'm doing the same stuff here. I'm just rotating. I'm stretching this 2 to be 3 times as long. Ready? 1, 2, 3. Right? 1, 2, 3. And then I'm rotating it, and I'm rotating it by 180 degrees, and I end up over here at -6. Okay, so if we do that operation using the more general form up here, we end up with 6 at an angle of 180, okay, which is equal to -6. So we might think of that on the number line in this way. So all along, this whole negative times a positive and positive, you know, negative times a negative and all that stuff is really just stretching and rotating. Okay, we can do the same thing if we have, come here, -2 and -3. Okay, and we do that. So negative times a negative is going to be a positive, right? So that's going to be +6. And here's how I want you to think of that one. Not as -2 and -3. I want you to think of it as 2 at an angle of 180 and 3 at an angle of 180. Okay, so now let's use that more general form. We take the, let's say we take the 3 and stretch it to be twice as long, and then we add the angles, 180 plus 180, and we're going to be back up here. It's going to be 360, but 360 is the same as 0, right? And we're still on that real axis. Okay, so we're still stretching and rotating. A negative times a negative is really just 180 plus 180. And we get over here to 6 at an angle of 360, which is really 6 at an angle of 0, also known as +6. Okay, so we're stretching and rotating. And you've been doing this since grade school. You just didn't know you've been doing it. Okay, now we're going to do this in 2 dimensions. We're going to stretch and we're going to rotate. Okay, I do like doing this one on the board more. So here's a 2D example. Okay, 2D. Am I running out of paper here? Nope, I'm good. Okay, 2D example. 2 at an angle of 125 times 3 at an angle of negative 45. Okay, so let's see. Let's get the two operands there. Oh, I feel like some colors would help us here. And I don't have these in color. 2 at an angle of 125. That's our blue one, right? And 3 at an angle of negative 45. That's our red one, right? So I do like doing this in person more. Orange is going to be our result, right? So if I take 2 at an angle of 125 and I stretch it to be 3 times as long, it's going to be out here at 6 at an angle of 125. Then if I add the angles, 125 and negative 45, whoop, I'm going to rotate till I'm over here at 6 at an angle of 80. Okay. Now, multiplication is commutative, and that just means that I can flip these around. I could say, hey, take this 3 at an angle of negative 45, stretch it to be twice as long, so I'm out here at 6 again, and then rotate it by 125. So negative 45 plus 125 is going to rotate me up here to 6 at an angle of 80. All right? Stretching and rotating. Multiplication is stretching and rotating. And we're going to use this. We're going to use this to say how much does a resistor take a voltage and stretch it so that it turns into the current. Or how much does a capacitor take that same voltage and stretch it, but also rotate it, okay, to turn it into the current. So stretching and rotating. This one's going to be real important for us. I want to build up to division. And if we got to go to division, we have to take a trip through inversion. All right? So stay tuned and good luck, folks.